Good evening, all. Good evening, all. You are welcome to the tutorials with Famantine the Schoolboy. Today we'll take a look at physics, and the topic for today is measurement of volume. Remember, we are still discussing measurement and what units. Measurement and what units. So, in our last class, we concluded with measurement of length. We concluded with what? Measurement of what? Length. So today, we go over to what? Measurement of what? Volume. Measurement of volume. So, under this measurement of volume, we'll take a look at measurement of solids. Then after that, we'll go to measurement of what? Liquids. So we'll look at solids, volume of solids, volume of what? Solids and what? Volume of what? Liquids. We'll look at measurement of volume of solids and volume of what? Liquids. Under solids, we'll look at measurement of volume of what? Regular solids and what? Irregular what? Solids. So let's start with measurement of the volume of regular solids. Measurement of volume of what? Of course, you know that solid volume is measured in what? In what? cm what? Cm what? Cube, right? But actually, you can have meter cube, mainly anyway, SI unit, right? Then we have male. Male and cm cube are the same thing. Okay? Okay? So let us not talk too much on that. They are no longer new. So now let's look at regular what? Regular what? Solids. Now, examples of regular solids I want us to look at is, one is rectangular block. Rectangular block. Let's look at rectangular block. Let's look at what? Rectangular what? Block. Now, if you, of course, now, for you to calculate the volume of a rectangular block, you just remember your mathematics. What are you going to do? You check the volume of the what? The block. True or false? Volume of a rectangular block in your mathematics is what? Length times what? Length times what? Length times breadth times what? Height. It's not. It's not. For a rectangular block, volume is what? Volume is what? Length times what? Breadth times what? Height. This is the volume of what? Formula for volume. So if you go to a rectangular block, you use your distance, your LBH, length, breadth, and height. They are all measure of what? Length. True or false? True or false? Measure of distance. True or false? Now, with the length now, depending on the length, you can use your meter rule. True or false? You can use your what? Your metric rule, like this, small metric rule like this, to measure the what? The length. True or false? You can use it to measure. The rectangular block is something like this. Something like this. In your physics practical, you are prism. Remember? Can you remember? Something like this. You can measure the length. True or false? True or false? Good. Then you can measure the length with your metric rule. You can also measure the what? The breadth, right? This one, this height, you can also use this thing, hope you know, meter rule, right? Because it's not that small, it's not that tiny that you can go and start using your micrometer screw gauge. Depending on the thickness anyway, okay, or the height. You can use either this or micrometer screw gauge. So if you measure this and multiply it, you go to the what? The volume. It's simple. It's not hard to do, okay? For the rectangular block. Another one I want us to look at is volume of a sphere. These things are regular. When you hear regular, solid, it means solid with a definite what? Shape. Regular solid are solid with what? A definite what? Shape. Rectangular block is rectangular. It has a definite shape. At least it has a definite shape. I follow you, Michael. Then a sphere has a definite shape. True of us, small ball. Even your simple pendulum, you use it. Your simple pendulum practical. Who has seen it before? Simple pendulum bulb. That small thing is a sphere. It's not a sphere. You can check the volume. So, how do you know the volume? What is the volume of a sphere in your mathematics? Who can tell us? You don't know. The volume is what? 4/3 pi what? R what? Cube. 4/3 pi R what? Cube. Are we together? That's the volume of a sphere. Now, how will you determine where the question lies now? If you get that sphere, how will you determine the radius of the sphere? That's where the problem lies. Because once you determine the radius, pi is a constant. True of us, you can get the volume. So you can determine the volume of the radius of the sphere. Remember, you can determine the diameter of the sphere. Is that pendulum bulb is small, right? You can determine the diameter using micrometer screw gauge. True or false? Remember, when we discuss micrometer screw gauge, you can determine the diameter of your pendulum bulb using what? Micrometer screw gauge. So if you calculate the diameter of that bulb using micrometer screw gauge, radius is diameter over 2. Is it true? Radius is half of what? Diameter. Remember that radius is what? Diameter over what? 2. So if you use your micrometer screw gauge to get the diameter, you divide it by 2. You get your what? Radius. But it's always good to check it, do it like 3 times and find the what? Average. Okay? For accuracy, measure it 3 times, okay? And find the average. Use the average to get your R, okay? Average diameter. Check the diameter for the first time, record it. Check the diameter for the second time, record it. Check again and record it. And find the average. When you find the average diameter, you divide it by 2 to find your what? Radius. You now put the radius here. And use it to calculate the volume of the what? Sphere. It's simple, right? Good. That is another one. Then another one is this. Cylindrical wire, a cylinder. Maybe you have a cylindrical wire or a cylinder, anyone. You can say cylindrical wire, anyone. But just know that a cylindrical wire has the shape of what? Cylinder, right? So it has a definite what? Shape. True or false? True or false? Wire now, your wire. It's not cylindrical. Is it now? It's not good. Now, how do you now get the volume? What is the volume of a cylinder in your mathematics? Pi r what? Good. Or pi r square L. I like that. For cylinder is what? Pi r square what? L or height. Any of them is okay. Pi r square what? So for a cylinder now, if you know the cylinder now, there are 2 things you check in the cylinder. In the cylindrical wire, you check the length of the what? Cylindrical wire. True or false? You check the length and the what? Diameter. True or false? Good. You check the length and the what? Diameter. Now, If let's assume this is the wire in question, okay, you can get the length using your meter rule. True or false? True or false? You can determine the length using what? Meter rule. Have you seen why we did what we did? So that by the time we get to volume, it will be easier for us. You check the length using what? Your what? Meter rule. Then you use your micrometer screw gauge to determine the what? Diameter. True or false? Use your micrometer what? Screw gauge to determine the what? Diameter. So if you use a micrometer screw gauge to determine the diameter, see what you will get. But be careful, you know, along the length of the wire, they may differ. Okay? So you can use meter rule. You use meter rule, check the length. Then for the diameter, use the micrometer screw gauge, check the diameter at different points along the length, okay? Okay? Use your meter rule to just check the height, the length, right? But when using your micrometer screw gauge, don't just check the mouth and stop. Check the diameter at this point and record it. Check the diameter at another point, maybe in the middle, and record it. Also check the diameter maybe towards the end here and do what? Record it. After you find the average what? The diameter. Before you now find your what? Radius. Remember that radius is the diameter. But any question? Ask. How can you do what? In the middle. Good question. I like that question. I like that question. Meter screw gauge operate, right? You know how it looks like. You have your what? This is the frame, right? Right? We have the two arms, right? This is spindle, something like this. And the scale is here, right? Now, if you put the thing here, if you put the wire like this, if you put the wire like this, you tight it to hook it, you get the diameter. Put it like this. Just try to put it like this now. Is that true? Is that true? This is like this now. You hold it like this and put the wire like this. If you carry this like this and hold like this, just hold it like this in your hand. Then you put the wire like this. You check the diameter. It's not true. If you tighten this place, it will close up. It's not true. You check the diameter at this knees at the beginning, check it at the middle, check it at towards the end. Okay? Maybe about three portions along the length. You now find the average what? Diameter. If you find the average diameter, you now find the what? Radius. Remember that radius is what? Diameter over what? 2. You find the radius. When you are done, you now calculate the volume. Pi r square what? Then, and you get the volume of the what? Cylindrical what? Wire. Is it clear? Is it clear? Yes. Okay. We have done that. We can't be going back every day. Hey, yeah, she came late. Aye, shy. Are you on WhatsApp? But your mom is on WhatsApp, right? See what happen. I'll add your mom to the group. Then maybe I'll repost that lecture. You can listen to it. Okay? Will you do that? We can't be going back to that to and fro. It will make us to be stagnant. That's why I record our lectures. Okay? All right. We have done that. But I'll give assignment on it today again. Maybe if you're reviewing the assignment tomorrow, you may in the assignment I'll give today, vernier caliper is there, micrometer screw gauge is also there. So with that now, by the time we review it tomorrow, at least from there you can, and if you also listen to it today, then by the time we review to tomorrow, you now, it will become clearer to you, okay? All right. So, that is the, for what? Cylindrical what? Why? Now, let's stop here for now. Let's look at irregular what? Solids. You know, a solid that is irregular, just like a lump of stone, or maybe a wood that is scattered. This side is like this. One side is like this. One side is like this. There's no shape. A stone scattered, no shape, no definite shape. You cannot say it's rectangular. You cannot say it's circular. You cannot say it's a what? Spherical. It just no particular shape. You cannot get the volume using this thing, this formula. It cannot work for you. The only way to do it is to do what? Use the method I want to describe now. Now let me ask a question. If you get a solid and put in water, let's assume now this is water. This is a bucket or a tube or whatever that contains water, and you put this solid without a definite shape and put it here. What the water put in liquid? The volume will do what? True of us. If you carry this thing now and put inside this water, the volume will do what? Increase. If this thing is here now, the volume will do what? Increase. It will come to this level. Do you know what displaces this water? Is this solid here, okay? This solid displaces the water. Now, this water from here to here, if you measure it now, if you measure the volume of water from here to here, if you take out this water now from here to here and measure the volume of this water is the volume of this solid you put inside it. Okay? Is the volume of the what? The solid you put what? Inside it. Provided that the solid does not dissolve in that water. Provided that the solid is insoluble in the water. It doesn't even need to form a suspension. The water should not even dissolve any part of it at all before you can get the exact volume, okay? So that solid you put inside is that is the volume. So this is how you can check the volume of an irregular solid. Just put water. Put it in water or any liquid. It must not be water. Any liquid, it cannot dissolve inside. You put it, check the volume of that liquid displaced. If you're able to collect that exact volume and measure, that is the volume of the solid you put inside. Because it's that solid that make it to do what? Come up. Because the solid displaced the water, or the size of that solid that displaced exactly the size of the water, so it can accommodate it. True of us. Good. Had it been the water cannot be displaced, the solid can never enter inside. Get a sand now, pack a sand, put it here, and drop the solid on the sand. Will it enter? Because the sand is denser, it don't enter. True of us. So, but because it's denser than this liquid, if density of that solid is more than that liquid, if you put it, it just enter and move the liquid up, displace the liquid up. So that volume of the liquid displaced is the volume of that substance.
But how can you use to measure the volume of the liquid displaced?
Good. Now, I just introduced this now. I want to explain what will happen now. Now, have you heard of what is called? Have you heard of Eureka? Eureka. Eureka tube or whatever. Okay. Now look at it now. To be able to do this, now see what you will do. You get Eureka, something like this. Okay? Then use use cylinder, measuring cylinder. Okay? Use what? Measuring cylinder, graduated cylinder to collect the liquid that will come out. Okay? This is graduated in mils. Can you see it now? Huh? This thing is graduated in mils or CMQ, depending. I think the one in most labs is mils. The one in your lab, is it mils or CMQ? Is mil, right? Good. It's graduated, right? Now, the water may be somewhere here. The water is somewhere here. You now open the top and add the irregular solid. If you add the irregular solid, the water will offshoot, and as water is rising, it will enter into this place. Okay. Now, if it enters finish, if it enters TBL, if the water maintain a steady level, that means it has the volume displaced has all entered here. True or false? Now you now measure the volume here in this measuring cylinder. This volume you measure, what number of mils it is, will give you the volume of what you put inside. Is it clear now? You didn't answer your question. So we call this thing Eureka.
Where will the water be at the first before you put it?
Huh?
Where will the water be before you put it?
Where will water be? Of course, the water should not. The water can be anywhere here, close to this place. Okay, that's where the water should be anyway. The water should be close to this junction. Yes, so that if you add, you can get exactly. If you add it now, if you add the solid, it will go up and start going down. Anything that comes up will go down. True or false? If the initial level of water is here, anything, even if you like, add rice, a grain of rice inside it, some water will, displaced water will come up. True or false? So if you add that solid, anything displaced will go up, and as they are going up, they will be leaving through this place and entering here until they maintain a steady level. That means by the time if they maintain this steady level, that means everything displaced has entered. You can now measure it and put down and write down the volume. That is the volume of the solid you added. That is irregular what? Solid. Remember the condition. The solid should not dissolve. Should be insoluble in the what? Not water. Liquid you are using. It must not be water. Okay? That means if you have something that will dissolve in water, use another liquid. True or false? Like what is it?
What if the irregular solid you are using, the upthrust in the water can float it?
Can do what?
Can float the solid.
The upthrust in water can float this solid, but will anything at all leave? Do you think there will be any displacement at all? No. Then you look for another liquid that will not have so much upthrust in it. It mustn't be water. I hope you know. Are you aware? It mustn't be water. It mustn't be water. That's why you're a scientist. These are things you find out in your experiments. Even though water, the upthrust, there may be other liquid that may not exert the same thing. True or false? What matters is for you to achieve. That's why he didn't say it must be water. But the only condition is that that liquid, that thing should not dissolve in the liquid in question. But I like your question. It's good. I like that. That means you are thinking. Remember from the beginning I talked about the density, right? Remember I talked about density of whatever you want to check. Depends on the two of them, whether they can, but mainly. But give me an example of something that if you put it, you cannot even no drop no drop at all of water will go. Give me an example of such liquid or such substance. You think not even 1 mil will go when this is at the top. Is that what you think? Nylon. You think no mil can even go drop? You think so? Try it and see. Try it. Try go there. Just try it. But the problem is we have to get this Judeka, because this is the only thing that can give you exactly what will happen there. You know, if you just put it in water, you won't see anything. I remember the volume of the volume of the what is it called? The surface area of where you are putting it is also matters. Also matters. So people you know. If you go and put it in a drum, big drum, you won't see anything now. True of us. You won't notice any displacement at all. But in a tiny thing like this, try it and see if anything will happen. I like your reason. This is how we should reason like scientists. I like that. Any question? Any other question? Now let's look at measurement of liquids. Volume of liquids. Volume of what? Liquids. Okay, now let's look at measurement of liquids. So the volume of liquids can be measured using a measuring cylinder. Remember the one Elimeri is the graduated measuring cylinder we use here. Remember? So volume of liquid can be measured using what? Measuring cylinder, a pipette, or what? Burette. Measuring cylinder, pipette, or what? You can use measuring what? Cylinder, pipette or pipette, the one they call it, and what? Burette. Can you measuring cylinder, pipette, or what? Burette. That R is single R, not double R. Burette. Even the volumetric flask. You know the volumetric flask, right? The one that has big bum like this. You know this one, right? Huh? You know this one, a conical flask, right? Right? Good. So you can measure the liquid, you can measure the volume of liquid using any of these things. Depending on the volume you want to do what? Measure. Depending on the volume you want to measure, you can measure using any of these. Then remember, in our first or second class on this measurement, we talked about reading of meniscus. Please, if you want to measure if you want to read, like now this water we collected here. If you want to read, let's assume this is the volumetric flask. This is your measuring cylinder, and the water is somewhere here, or the liquid is somewhere here. Please, there are three things that may happen to you. You have this thing. Something may happen here. You have this place. You have this place. Please be careful as you are reading the level, or in the measuring cylinder. Be careful. Please don't read from where up like this, okay? You make mistake. This is what is called meniscus. This is called what? Meniscus. This curvature here. Don't read from the top. Don't read from the what? You can make mistake reading. Read, place it, stay, check it at the eye level, okay? Then read under the curvature, under that curvature, under the meniscus. Read under the meniscus. The reading under the meniscus is the accurate what? Reading. Don't read by the side like this. Let your eye be that place, that the bottom of that curve stretch. That's the correct what? Reading. So this is precaution you take to avoid error due to what? Parallax. To avoid error due to what? Parallax. So this is how you can read the volume in a measuring what? Cylinder and on any other one. Any other thing you are using to do what? Measure liquid. Any question? Any question? Are you sure? Okay. Do you agree with me? Who agree with me? Raise your hand, let me see. You wanted to be going by 6:30. Let me see your hand. 6:30. If you wanted to be going by 6, let me see your hand. 6 dot. Let me see your hand. If you wanted to go by 6 dot, let me see your hand. Only one person. You wanted to go by 6:30. Let me see your hand. 6:30. Let me see your hand. Can't see. Guy, go there. No, can't see. Okay, if you wanted to go by after 6, let me see your hand. After 6. She know that after 6 is not time. So I want us to let be specific. It's okay now. I've heard your own. I'll let them to tell their own. Are you forcing us to go by your own? You alone. Nobody's with you. They don't want to go by 6. Nobody's with you. Who want to go by 6? Nobody apart from Chinwe. Who want to go by 6:30? 6:15. 6:15. 7 o'clock. Michael, which one do you want, Michael? 6 dots. But why didn't you raise your hand up? Why didn't you raise your hand? Who want to go by 6? Let me see your hands. I'm going to take a decision now with this thing I'm doing now. So say your mind on time. Oh. Raise your hand properly if you want to go by 6 dots. Properly. Yes, raise it high. 6 dots. Yeah, 3 against 3. Okay, if you want to go by after 6, maybe anything after 6. Let me see your hands up. 2. Where do you belong to? 7:30. Okay, 6 p.m. people have it. So please, 6 dots will go. Okay, so that you don't. It's not even a good thing to be going late anyway. Going back late anyway. Each time you leave here by 7, my mind is not always at peace. I'll just sometimes your parents will calling me. Where are they now? Haven't they come out? This been long they've left? I don't want to answer that call again. So I think we'll stop here. But before we go, I want you to look at this assignment we have. We'll review tomorrow. Please put down these assignments. Who copy it on the board for us? Who will copy it and copy it well? Who? Okay, let me look for someone that will copy it. All right, thank you very much for your attention. See you tomorrow. And God bless you.